Hi, my name is Daniel Blackburn, and this is the second part video of our practical in SWAE4401 Water and Nutrient Cycling in Soil Plant Environment. This is the second video of the practical on macronutrient deficiency on plants. Last video we spoke about overall visual effects on the plants and about the biomass reduction under these macronutrient deficiencies. Today we're going to talk about the concentration of phosphorus and potassium on these plant tissues. All right, so this is the second video about the macronutrient deficient experiment, and I will give a quick revision about this experiment, but you should watch the previous video for more details. We're gonna go straight for the analysis of these nutrient deficiencies on the plant tissue. So this is how the experiment was set up. We have a very depleted soil, very low in all macronutrients, nitrogen, phosphorus, and potassium. We used as a fertilizer source for phosphorus, triple superphosphate. For nitrogen, we had urea. And for potassium, we had potassium chloride. So we set up pots with all three macronutrients with -N. It is to say only with the supply of phosphorus and potassium, -P, only with the supply of potassium and nitrogen. And we have it with -K, only with the supply of phosphorus and nitrogen. So this is how the plants look like when we harvested them. The big plants here are the NPK ones, and the other smaller ones are the ones with macronutrient deficiency. So about the biomass, we showed that in the last practical. You should watch that video if you want to have a look in biomass and symptoms. But now we're going to jump directly into the analysis of plant tissue. So how do we do this analysis? We chose one method of digesting this plant material. Actually, what we're doing now is only ashing the material on the furnace. So we set up after we measure the dry weight. For the last practical, we said we use data of fresh weight and dry weight, and now we are taking the same plant material that we use for dry weight, and we are burning it up on the furnace, and this is how it looks like on the furnace. And then we proceed to dissolve the ashes on acid. Okay, so this is how it looks like. This is first video here is Lilwa adding acid for the ashes, and in order to dissolve this ash material, the phosphorus and the potassium on the ash material. The second video, just shaking around and mixing well, and then we leave it to rest under extraction fume hood. And after 1 hour, we filter this material up. So the filtrate is what we're going to analyze for phosphorus and potassium. So the potassium measurement is the same measurement as we did it for soil extract. So we just need for more details, please watch the video on potassium on soil extract and potassium bioavailability to plants. But now we are actually doing the same thing, but only for the plant material. Yeah, so we're going to calibrate the equipment, set up the zero. And after we set up the zero, we set up the standards. And after setting up the standards, we can then proceed and read. This is setting up the standards here. And after this, we can proceed and read our sample. Yeah, so we can read our samples. And the concentration, this is of course is a diluted sample or filtrate. We have to dilute it 100 times for measuring in order to have a good range of concentration for the measurement. And for the measurement of the phosphorus concentration, we're going to use the same procedure that we had for also using the moly blue phosphorus. So for the moly blue phosphorus, we need to prepare these 4 solutions. There is a sulfuric acid solution, 2.5 molar, ammonium molybdate solution, and a potassium antimony tartrate solution, and an ascorbic acid solution. So these 4 solutions we need to make freshly and mix them freshly before we develop color in these samples. Yeah, this is also showing Lilwa preparing the solutions, which is you can go back and see the previous video for that on the moly blue measurement. Yeah. So what we need to do is mix freshly 10 mL of reagent A, 3 mL of reagent B, 1 mL of reagent C, and 6 mL of reagent D. And this will be the color development solution that we're going to add to our samples and for our standards also. Okay. So yeah, this is Lilwa preparing that mixed reagent solution. Yeah. So for the measurement, this is what we showed before in the previous class where we talked about measuring phosphorus in soil extracts. So this is Lilwa here, and she's pipetting the standards 0, 0.1, 0.2, 0.4, 0.6, 0.8, and 1 ppms into the microplate. And this is 200 microliters of this standards and samples that are being pipetted into the microplate. The first one, of course, on the curve is water, and just the 0 concentration is water, and then you have the rest of the curve being pipetted on the first 2 columns of the microplate. And after we have this pipetting of the samples, we add 40 microliters of the mixed reagent to each one of these wells of the microplate, and also we added to our samples also, which in our case now will be the diluted extract from the plant, from the ashes of the plant material. And then we have to multiply back by these dilutions in order to get the concentrations that we have. Okay. After this, adding the color development reagent, we leave it 15 minutes for developing color. You can see here how is the gradient of the curve, and then here's some samples. And then we proceed to measure this on the microplate, on the plate reader at 880 nanometers for this method. And then after that, we will have the calculations will be done similarly to what we did for soil extracts. The only thing is we have now to multiply by the dilutions we have, and then we have to divide now, instead of dividing by the grams of soil that we used, we have to divide by the grams of dry weight that we had on the plant material. So total volume, we have to have the total amount of phosphorus on the extract, multiplying by the dilutions and by the total volume of the extract, and then we divide by the number of grams of dry weight material we have before ashing, and then we're going to have this concentration as milligrams per gram of plant material. Okay, so I will give you the spreadsheet for these calculations, and for more details on these calculations, please watch the previous videos, the practical on the moly blue P, and also on the potassium measurements in soil extracts. And the calculation will be, the procedure and calculation are similar. It's just now that instead of analyzing an extract for the soils, we are analyzing the filtrate from the dissolved ashes from the plant material. Okay, that's all for today's practical, and see you on the next lecture.